Hi, welcome to my video on graphing y prime and y double prime from the graphs of polynomial functions. Graphing y prime and y double prime for each. Number one, as you can see, we have a graph, and this is a linear, and y equals mx plus b, where m is the slope and b is the y-intercept. And the slope is greater than 0. That's why it's greater than 0 is positive, so it's moving up to the right. So if we do the derivative, which is y prime, derivative of mx is the slope m, derivative of a constant is 0. So we have y prime equals m. Excuse me. So y prime equals m, that's a number, as a constant, so it's positive, so that means y prime is up right here. Slope of a horizontal line, let's say that's slope is 2, so this is y prime is 2, so that's y equals 2. And the derivative of y prime is y double prime, and the derivative of a constant is 0, so y equals 0. That's along this line right here. So this is y double prime. So number 2 is the same. It's a linear, but this time the slope is m is less than 0, so the slope is negative. And again, y prime derivative is m. Derivative of b is 0. So that because m is negative, that means that y prime is a negative number, so that means it's down below here. M could be any number negative, so this is y prime. And when we do y double prime, so the derivative of a constant is 0. So because this is 0, so it's the same as number 1, it's right along here. So this is y double prime. Now we have number 3, and number 3 is a quadratic, a parabola, and a is greater than 0, so there's a parabola open up. This is the vertex right here. And if we do the derivative of we'll go back to here. This is a linear, so the derivative of a linear is a constant, and the derivative of a constant is 0. And y prime here, this is a quadratic, so y prime is 2ax plus b. And there's the vertex is right here. So whatever the value of this vertex is, we drop perpendicular to the x-axis. And on this vertical line, all x values are the same. So whatever x is here in the vertex, that's what this value is right here. So when we look at its derivative, which is linear, as a line, so if we knew what this line was, we could plot the y-intercept, and which is down here, because the slope is going to be positive because a is greater than 0. The y-intercept would be here passing through this point, so the line would be going like this. But in relation to the slope of the parabola, on this side on the right side of this point, the slope is positive. So that means all the values of this linear function will be the slope of each of those tangents. So there's y prime there, so this is positive, so it moves up. So this is going to be y prime. And on this side of the point, this slope is negative. So this is all values are going to be negative down here. But the slope is 2a on this line. And that's y prime, and y double prime is the derivative of 2ax, which is 2a. Derivative of b is 0. So notice this is a quadratic going to a linear, going to a constant. So, and since a is greater than 0, 2a is positive, so y equals 2a is a horizontal line up here, and that's y double prime. This is 2a, so if a was 3, this would be y prime equals 6. So there's y equals 6, a horizontal line up here being positive. And we have a same parabola here. Excuse me. This is a parabola, but notice the parabola is open and down as a quadratic, and a is less than 0, so that's why the parabola is open and down. So this is the vertex, so whatever x value is here, drop a perpendicular, and we get an same x value here. Now let's look at the derivative. Y prime is 2ax plus b, and we look at, this is a linear, so that means this y-intercept is going to be negative from on this point. So if you plot this line, we get a negative. But if take this value of x here, the slope of this curve right here is negative. So that means it's down below. And on this side, the slope of this curve is positive, so the values are above the x-axis. So this is y prime. And if we do the second derivative, which is y double prime, derivative of 2ax is 2a, derivative of b is 0. Again, this is a constant, but a is less than 0, so 2a is negative, so this horizontal line is down below here. And so this is y double prime. Again, a quadratic, derivative goes to linear, derivative of linear goes to a constant, which is a horizontal line. Okay, let's do some more. Another page here. And get everything fixed up. Okay, here we go. Notice now that we have, this is a cubic, cuts here, here, and here, 3 intercepts, but this is the graph. A is positive, so that means it comes down from the top. X-intercept here bends, X-intercept here, and bends again. So if you expand this equation out, you get an A. X times X times X is X cubed. So if you expand that out, the leading term will be AX cubed. Then it would be X squared, and then it would be X and a constant. So if we looking at the derivative of that cubic, again there's the cubic. The derivative is y prime. So it would be 3 times a, which is 3a, and the exponent drops by 1. And then there's more to follow. I'm concerned with just with this one. So this is a quadratic. So we look at the highest and the lowest point. So the lowest point on this cubic is right here. So we drop a perpendicular to the x-axis. The highest point is right here. Or when I say the highest point, it's the highest local point. This is the point as x goes to infinity. This graph goes on to infinity. Y goes to infinity. And also as x goes to negative infinity, y goes to negative infinity. So this is what we call a local minimum and local maximum. Drop a perpendicular. So the x value of this point is right here. And the x value of this point is right here. So on this side of this point, this is a positive. So because it's positive, that means it's going upward. All the values of this tangent is going here. And from this point here, to these two values, this curve is, this is a negative slope. So that means it bends and it comes like this to form a parabola. Remember, this is a cubic, and therefore the derivative of a cubic is a quadratic. So it has to bend. Because the slope is negative, it goes down below. These values in here for the tangent are going to be negative numbers. And on this side of this point right here, this is positive slope. So that means it's going up here. So this is y prime. Again, this is a cubic. Derivative is a quadratic. Now, if we look at the red drawn, let's say this is the vertex of this parabola that we've drawn. Then we drop a perpendicular to the x-axis right there. So the value of x for this vertex is the same as right here. So now we get a linear. So on this side, this is a quadratic x squared. Oh, I better do the second derivative. Second derivative is 3 times 2 is 6ax plus a number. Again, a is greater than 0, so 6a is positive. So this is the slope that's positive. So positive means on this side of the curve we have a slope is positive, so the numbers, a linear goes above. And on this side of this point, this is this point right here. On this side is positive, so we're above. On this side is negative, so we're down below. So this is y double prime. And again, y double prime is linear. It's a line that passes through this point, which is the same coordinate as the vertex. And we have number 6, very similar to the one we just did, only a is less than 0. It means we're coming up from the bottom. Because it's negative, we come up from the bottom. It's negative down here. And it has 1, 2, 3x intercepts. And we expand this equation out. We get y equals a, x cubed again, and x squared, and x and a constant. As a result, we have a cubic, and we have the y prime is the derivative. We have 3ax squared plus x and plus a number, a constant. So if we take this point right here, which is the maximum point, local maximum, drop a perpendicular, we take this point, which is a local minimum, and drop a perpendicular. So the value of x here is the same as the x coordinate of this point. The value of x here is the same as the value of x of this point. And a is less than 0, so that means this parabola is this 2 or 3a is going to be negative. So that means the parabola is opening down. Well, let's see. On this side of the point, this is a negative. So that means if that's a negative, so from here we draw a negative. All the values are negative. And if we take it on this side, of this point right here, the slope is negative. So the values of the value of the slope of the tangents is negative, so it goes this way. And between these 2 points, this slope is positive slope, so it's going up above. So it's a positive slope, so we're staying above. From here to here, we're above. Notice from this side, it's negative, so we're down below. On this side is a negative, so we're down below. So there's, when you take the derivative of a cubic, you get a quadratic. A quadratic is a parabola. Okay, now let's do the second derivative. And 2 times 3a is 6ax plus, that's an a, plus a constant. So notice a quadratic derivative goes to a linear. So the linear here, so whatever the value of this point is here, we drop a perpendicular to here, right there. And so on this side of this point, the slope is negative. So that means we have to drop part of a line, and on this side is positive. So the values are positive, and this is y double prime. And again, because this is a is negative, 6a is negative, so this line has a negative slope. And we have another one, which is just is a cubic, but it's just that the point, this cubic passes through the point 0, 0. And it's positive means it's coming down from the top and bending. So when we do y prime, we get 3ax squared. And 3ax squared is a parabola. So we take this point, and on this side is positive, so parabola moves up like this because it's positive. And notice that on this side, the slope is the slope of the tangents is still positive. So this is positive. So at this point, the parabola is opening up like that. And when we do double prime, we get 2 times 3a is 6ax. And so notice that the vertex of this parabola is 0, 0, because when x is 0, y is 0. And this is, again, the same point when x is 0, y is 0. So this same point, 0, 0, is for all the original equation, the derivative, and the double derivative. And this is a linear passing through 0. But we have this is a positive slope. So it's a linear, so it goes through like this. And, this is, I didn't do my blue. I better put this in blue because I'm doing my second derivative in blue, not in red. Red is the first derivative. So my blue is going up through here like this and down through here like this. So this is the second derivative. And this one is the first derivative. So the first derivative of a cubic is a quadratic. So there's the quadratic. And the derivative of a quadratic is a linear, and there's the linear. Now I want to finalize a quartic. The quartic has power of 4. So let me explain. So notice it has 1, 2, 3, 4 x-intercepts. So when I expand this equation, I get y equals a, x times x times x times x is x to the 4th. And it goes on. Notice I have 3, 4 brackets, so I have 4 intercepts. 1, 2, 3, 4. Now, when I do the first derivative, this is quartics, degree 4. So when I do the first derivative, I should get, this is 4 times a x cubed plus x squared plus x plus a constant. So because it's a cubic, we have to graph a cubic, and a cubic will look like this most of the time. So this is the highest, this is the lowest point, so we drop a perpendicular to the x-axis right there. So the value of x for this point is the same value of x for this point right here. Okay, now we got a maximum point here, so we drop a perpendicular to the x-axis right here. And we have another minimum point, so we drop a perpendicular to the x-axis. Same as we did right here, only we only have one max and one min. Now we have 2 mins and a max. So it ends up to be, remember, this is a quartic, it ends up to be a cubic. So how do we draw the cubic? Well, on this side of the point, this curve is positive. So that means if this slope is positive, from this point here, I have to go upward like this, because this is the values of y prime. This is going to be y prime. The values of the slope of the tangents are going to be positive. So in between this point and this point, the slope of this curve that's a negative slope. If you draw a tangent, you get negative. So that means from here to here, we got all negative numbers. So we have to make, it's going to come down and hit here, and then it's going to bend and go up through this point. So all these values of x that's on this curve here, and here they are, here's the slope. That's the slope of, and again, it's not a perfect cubic, but, and from here to here, from this point to this point, this slope of this curve is positive. So that means all these positive values are here, like this. And on this side of this point, right here, on this side, this is a negative. So it comes on down here, negative. So again, the slope is negative. So these are the values that are going to be negative down below. So notice y prime is a cubic, just like this one right here. So down, peak point, up, maximum point, down again. So that's the cubic. So when we do y double prime on this cubic, we get 12ax squared plus x plus a constant. And again, because this is positive, this parabola, excuse me, is going to be positive. 12a is positive. Excuse me. So this is a peak point, so we drop a perpendicular to the x-axis. And this is the peak point, so we drop a perpendicular to the x-axis. So we have to look at, we're not looking at the quartics, we're looking at the cubic now, the derivative of the cubic. So on this side of the value of x here is the same as here. So this slope is positive, so that means it's opening up like this. So this is y double prime, which is going to be a parabola. And from the parabola is here, from here to here, the slope of this cubic, that's a negative slope. So that means it comes down and like this, and it goes up to this point. So the values here are negative, so that means it's opening like that. Because the negative, these are y prime, the values of y are negative right here, pertaining to the double derivative. And on this side of the cubic, we have a positive, so that means it opens up to there, like that. All the values of this right here, all the values on this side of this cubic are positive, so that's where we're going up. So notice now y double prime is a parabola and y prime is a cubic. So that's graphing from drawing y prime and y double prime from a graph. And again, repeat, if you have a quartics and you do a derivative, you get a cubic. You do a second derivative, you get a quadratic. If you did another derivative on the quadratic, you get a linear. So it keeps going down the line as many times you want to do the derivatives of a derivative. And that brings us to the end of my video. And if you like the video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.